Hello and welcome. My name is Rafal and I'm joined by Parrish, Brian, and Jose. We are Group 1 presenting our final presentation on making a 100% AR-15 lower receiver. Traditionally, this part is first created by a cast molding method made out of aluminium. From that molding process, an 80% lower receiver is what comes out. An 80% lower receiver is an unfinished part that requires the end user to mill out and drill the last 20% to make a functioning receiver that can accept a lower parts kit. A lower receiver completed beyond 80% is considered a firearm by the BATFE, hence the name 80% lower. We, however, will be completing this project with a 3-axis mill CNC in mind, designed on Mastercam. This is the AR-15 lower receiver that we found and downloaded from GrabCAD.com. We imported the SLDPRT or SolidWorks file directly to Mastercam and set up the stock as shown. Now, as you can see, this piece has a lot of round edges, which makes it rather difficult to machine. Additionally, you also have the issue where the SolidWorks file treats the piece as a whole solid block. There is, however, good news. I have learned that in instances like these, you can actually create solid surfaces from the model itself and machine over the top of it. As you can see here, I have actually created a solid surface in the shape of what I want to machine. Unfortunately, a secondary problem arises in that I cannot select said surface as it is embedded in the solid piece itself. We can overcome this issue by untrimming the surface we just created, giving us a spot to click on, thus allowing us to select it. Now we can use a 3D toolpath, in this case a surface finish parallel, along with a ball and mill to machine this piece. This is obviously just a rough cut for demonstration purposes only. Now you may be thinking at this point that this is a lot of work for just a surface machining job, and you'd be damn right. But we haven't even gotten around to the second problem of this method. Because if we try to apply the same method to, let's say, this surface, you will note that it is impossible to select it even when you untrim it, as there is nothing to grab onto. So we have to resort to a secondary trick where we extend the surface we have just created such that it protrudes outside of its profile, thus allowing us to finally select it. And now you are able to machine this piece in the same exact way we did in the first surface. However, this method was far too painful. And after about a week's worth of work and over 63 operations, we had to call it quits as Mastercam itself was basically just fed up with our methods and began to make errors that I cannot even begin to describe or comprehend. The best way to go about this is to go back into SolidWorks and export the model as an IGS file, while making sure that the solid surface entities and the wireframe options are enabled. Now back in Mastercam at about a week smarter than we were before, we can finally get the ball rolling again. We will first start by taking the stock material out to get the general shape of the receiver with a 2D high-speed operation. The first operation had some stock left on it to take out most of the material, while the second operation had a smaller tool used in order to get the finer detail. We enabled rest material to make sure that the tool path was starting from the remaining material from the last operation. Next up, it was time to get all the flat parts on this side of the receiver done using a 1/8 flat end mill. We were unable to make this a single operation for all the flat parts, as a 2D operation requires a certain depth and does not recognize surfaces. As each of these flat parts were on a different elevation, we had to make separate operations for each flat area. Now, at first, I was doing these flat pieces with a 2D high-speed dynamic mill. When I was selecting my chain, I left the machining region to stay inside. What this inevitably did was leave burrs and leftover material that was impossible to remove even with the remachining operation. On top of all this insanity, I kept having to add an avoidance region, upon an avoidance region, upon an avoidance region, until I had about 11 of these. For some reason, Mastercam just wanted to destroy this piece, and so did I. Sometime later, a light finally came on, and I figured out that if I machine from the outside with these avoidance regions already in place, I should be able to machine through all of this leftover material. And thank Jehovah for that, as I was about to lose my mind trying to figure this out. As you can see, the tool is machining past the chain, but not through the avoidance region chain, which is getting rid of all the unwanted material. With all the flat parts done, it was time to get to work on all the curved surfaces using the surface finish parallel operation. This was just a rough pass to get the general shape. The second operation was done with no stock left on the walls with a finer tool. However, to do these 3 tubes would take about 4 hours and 54 minutes. As you saw, the tool was only moving back and forth in one axis direction. So my thoughts, correctly so, was to select only those surfaces that would line up well in the horizontal axis alone. And you also obviously want to make sure that you check all the surfaces that you do not want the tool to touch. Obviously, the second operation will have the vertical axis tubes while also checking the unwanted areas. Furthermore, you now need to change your machining angle to 90 degrees for the tool to machine vertically. Now, if you were to combine both operations, you will note that the time to completion is 4 hours and 38 minutes, so we save about 16 minutes. Similarly, we now have this surface to worry about. Unfortunately, it's not on a 0 or 90 degree axis, whereas instead it's off on a slightly funny angle. So if we leave the machining angle at 0 degrees, the outcome will be this weird uneven surface, even for a rough cut. Fortunately, I got lucky on my first try and set the machining angle to 10 degrees, which was exactly what we needed. Even though the machining time is 10 seconds longer, the end result is much nicer for a rough cut. And this is just the remachining of the same spot for a nice smooth surface. While working in that same area, we also went ahead and focused on the backside. As you can probably tell, the backside is not exactly flat. There is a bit of a slanted angle going on. So with another surface parallel finish, we can select the backside as shown, and then give her a whirl. Next up, we will use the surface parallel finish yet again with a much smaller tool in order to machine all the little curvatures on the edges. With the same operation, we can now finish the remaining surfaces on this side of the lower receiver with a 1/8 ball end mill, with some stock left for a rough pass. Then the same tool over again, but no stock left. All that's left to do now is to make the pocket and drill out all the holes. And we're done! Except we're not, since we still have to do all the other faces. Well, it's time to take this beauty and flip her over. A quick examination reveals that there are quite a few more avoidance regions to worry about here, including some new pockets and sharp angles to really work on. We're not trying to reinvent the wheel, so we are doing the same exact thing here as we did on the first side. This involves a 2D high speed over all the flat parts, then the occasional remachining to get rid of any leftover material. So far, we haven't done anything quite revolutionary, but the piece is starting to look quite nice. But alas, nothing can ever be too simple as we hit our first little obstacle. As you can see, we have 2 pockets to take care of. That one right there, and a second one up here that is actually co-joined with a pocket that needs to be done from another side. So the way we tackle this little conundrum is by using a contour 2D with a partial chain. Then, you only really need to concern yourself with one depth, which is from up here down to here. Since whatever is happening over on this side will get milled out when we do the pocket from the top of the receiver. The same holds true for our second pocket that also has a partial chain with a similar depth. And that's how it looks in action. Pay no mind to the partial pocket that's on top. It's just one of those moments you realize you have an extra operation from when you were experimenting with pockets, but hey, it looks great and that's what we were going for. You can ignore those little lines in there. Those are drawn in when we were trying to manually create some pockets by having a closed chain, not realizing you can use a partial chain to do these things. It's just little things that you learn along the way. And here we're looking at the exact same operations we had on the opposite side, so we're not gonna go over any of these. However, I will note that on this section over here, we did split up the operation for horizontal and vertical with the machining angles, so 90 and 0 degrees. With that side complete, it is now time to do the top side, where you will note we have several pockets that we need to create. So in order to complete the first pocket, we actually have to split it up into 2 operations, as there are some very sharp edges involved. So the first operation is just your standard pocket. However, we've left some stock on the walls just to get the general shape out there. But the second operation was set as a remachining of the first, where we used a smaller 1/32 flat end mill to get everything down to size. The second pocket was pretty straightforward. Select the bottom chain to mill out the inner contents, and that's that. As per usual, nothing is ever easy with Mastercam. So when we were doing the pocket over here, we actually experienced a little bit of a problem. There was leftover material in this section over here. And once the tool was doing its thing, you can see that the material is being left over. And we didn't quite know why. However, we did come up with a solution to this. If you go to the parameters and you change the cutting method from high speed to true spiral, then you can finally attain the shape that you require without any material left over. The elevated pocket over here, however, required 2 operations in order to get the sharp edges out, so a remachining pocket had to be used. Well, these pocket operations went without a hitch. That is until we hit this spot right here. As you can see, we have some leftover material that we don't want, like a filthy peasant. On closer inspection of the original model, it turns out that the material comes from this segment over here. This may be a problem, but we are engineers, and engineers must prevail. Thus, I selected a Contour 2D, and I did a partial chain from there to there. Next, I measured the distance between the 2 walls from here down to here. Why? Well, like an engineer, I work smart, not hard. Thus, I simplify this operation by having one swipe by selecting the appropriate diameter, which in this case is 0.44 inches. The purpose of all this is to have a single swipe operation to finish off the walls from the top and the bottom, instead of having 2 separate operations with a smaller tool. The last operation to do will be to make the pocket on the top, which will complete that pocket section entirely from both sides. This is also done with a partial chain in the Contour 2D option. With that side done, it is time to do the back. Remember that all these surfaces here are already done by previous operations. Thus, we only need to concern ourselves with this little spot. So, the plan is to use a flat end mill on this section, and then a ball end mill on these little arced spots. You do have to take care, however, because you will notice that because of this arc, if you do that bottom surface, there will be material where that arc is. Therefore, you actually need a second operation that will make sure to touch the walls on the side where the hole is. The only setback are the amount of checks necessary in order to make sure that the tool does not touch material that it's not supposed to. Once the machining is done, you only need to worry about the little arcs that are left over. Unfortunately, as we try to generate a toolpath for these surfaces, it kept failing. Upon closer inspection, it became evident that the arc was far too small for even the smallest of ball mill tools available, and we were forced to create a custom tool with a much smaller diameter. But with this new tool, the end result was pristine. With that complete, we can move on to the underside. Now, there isn't much to do, but we do need to straighten out that edge, and then create these 2 pockets, as well as this slanted surface where the magazine would go in. In order to do this section, we simply used 2 surface finish parallel operations, split into the horizontal and vertical axis. Although this operation did take a hot minute, the overall end result was actually quite pleasing. To alleviate this part's rounded edge when we did a general contour around our piece, we need to use a 2D contour with a partial chain and a flat end mill. And now it's time to do these 2 pockets over here. However, due to material still left over above the curvature, we also needed a 2D contour with a partial chain to swipe across and get the walls to their proper thickness. And because we are lazy, smart, we are going to choose a tool with a diameter that will allow us to do this in one go to cover both walls. We have also included a surface parallel finish to the little arc spots in between the walls as well. With the underside complete, we can now move on to the front of the piece, though technically this would be considered the back with the gun attached. Although that big hole is not an issue, this section on the inside is. As you can see, there is actually a chamfer, and in the drawings we did not have the angle of this chamfer, which meant that we had to guess the depth at which a chamfer mill had to go in to get that angle. But first things first, in order to do the circle, we used your standard run-of-the-mill pocket, and we selected this outer circle and then just used an end mill to drill it out. In a similar way, we also did a pocket on the inside of this circle. The fun part started when we had to come up with an accurate way of recreating this chamfer. We knew that we had to use a Contour 2D chamfer operation with a 1/4 inch chamfer mill, but we lacked the depth information. Just so you can see how aggravating this was, I will change the depth to 0 from -0.01 and see how big the difference actually is. So if we set the depth back to its original value, you will see that we did a pretty darn good job of getting it right on the money. I'll be honest, we had no clue how to get this surface to match exactly how it's supposed to be. Instead, we opted out for a rough look-alike by using a massive 1/2 inch drill bit, making it look somewhat right. We're happy with it, and so should you. Nothing to see here, we're moving on. The last operation for this surface would be to drill this hole right here. Unfortunately, it is located way down here. With no other options, we were left with having to create a custom tool that stretched to a whopping 5 inches. Well, we are almost done, as there are only 2 holes left to drill. However, the first hole is located over here on a very tight angle, and a second one over here. In order to drill these holes, we first had to change our axes through the plane manager. After figuring out the angle, we were able to start drilling from this face. So the first operation consisted of a spot drill, and then a 7/32 drill all the way through. And then our favorite problem surfaced. Chamfers, yeah! Using a 1/4-inch chamfer mill, we went ahead to the depth clickety thing and guessed our way to the correct answer. Lo and behold, I am getting good at this. And finally, we have arrived at our last 2 steps, leading up to a scorching hot 118 operations for our AR-15 lower receiver, where we simply spot drill and then drill this hole to the correct depth. And with that, ladies and gentlemen, my name is Rafal, accompanied by Parrish, Brian, and Jose. We are Group 1, and we thank you for joining us in this ridiculously wonderful ride on how to CNC machine an AR-15 lower receiver.